Hey everyone, Geek37 back for another video, and this is part 22 in my Exploring the Heptagonal Triangle series. And what we're going to do today is we're going to focus on finding the sum of the three cotangents of the angles of the heptagonal triangle. Now remember that the angles in the heptagonal triangle are pi over 7, 2 pi over 7, and 4 pi over 7, and that is what you see on screen before you. Now this is a bit of a I'd say medium to hard level calculation. And the easiest way to do this one I have found was to rewrite each of the cotangents in their reciprocal form, meaning put them as 1 over tangent, because that is the reciprocal of cotangent, or the reciprocal of tangent is equal to the cotangent of the given angle. Now, what I'm going to do next is I'm going to write a long fraction to start off with, and we have to find the common denominator. So I'm going to write off the tangent of 2 pi over 7 times the tangent of 4 pi over 7 plus the tangent of pi over 7 times the tangent of 4 pi over 7 plus the tangent of pi over 7 times the tangent of 2 pi over 7. That's the numerator because that is what happens after we find the common denominator, and we get the tangent of pi over 7 times the tangent of 2 pi over 7 times the tangent of 4 pi over 7. Now, if you remember before, the tangent of pi over 7 times the tangent of 2 pi over 7 times the tangent of 4 pi over 7 was equivalent to the negative square root of 7. So what I'm going to do down here is I'm going to write negative 1 over the square root of 7, because that square root of 7 and the negative sign should be in the denominator of the fraction. And then what I'll do is I'll write down tangent of the numerator, or excuse me, the quantity in that numerator. And I'll make it a little bit easier to solve. All right, give me a second. Okay, now that we have the screen clear and I have the last line moved to the top, let's change these tangents into their variable ratio forms. So the tangent of 2 pi over 7, as I have written down there, is b squared over cr. Tangent of 4 pi over 7 is negative c squared over ar, plus tangent of pi over 7 is a squared over br, times negative c squared over ar plus a squared over br times b squared over cr. And the nice thing here is we have a number of cancellations, so we can cancel off the c and the c squared, get a negative c. A and a squared, so we get an a. And then, of course, b and b squared, so we get a b. So we can reduce this down as negative 1 over the square root of 7 times the quantity negative b squared c over ar minus a c squared over br plus a squared b over cr, just like so there. And then what will happen next is we will replace those squareds in the numerators with the associated Ptolemaic identity that goes with it. So with b squared, I'm going to factor this. I'm going to factor this as negative a c times a plus c over ar. See if I get that right. Yep. And then we'll replace the c squared here with b. So we'll get a, b, and then I'll factor the b out. So it'll be a plus b on the inside here over br. Plus, and of course, a squared is equal to, so I'll put a b here, so it'll be c times c minus b all over cr. And then, of course, the a's will cancel, the b's will cancel, and the c's will cancel. And one thing you're going to notice here, and I'm sorry I forgot to do this correctly, these should be squareds right here because of the r's. So these are r squareds. My bad. So what will happen is I will factor out into the denominator on that outside fraction, outside the parentheses. We'll get negative 1 over square root 7r squared. And then on the inside, we are left with negative c, a plus c, minus a times a plus b, plus b times c minus b, just like so there. Okay, give me a second. All right, we got the last line algebra moved to the top here, so what we'll do is we will write the fraction on the outside, and then we will distribute through, so we'll get negative ac minus c squared minus a squared minus ab plus bc minus b squared, just like so here. Now, the interesting thing is, let's take a look at these three components on the inside here. Let me change that color just so it gets a little bright yellow. This part here, negative AB, negative AC, and BC. Well, if we remember back, one of the other Ptolemaic identities, I did not write it here, is BC equals AB plus AC. So if we were to get everything onto the one side, that would zero out. So basically, the BC, the negative AB, and the negative AC will cancel out, and here's what we are left with. Negative 1 over the square root of 7r squared, and inside the parentheses we get negative a squared minus b squared minus c squared. And what happens is, let's factor out a negative 1 from the parentheses, and all of these will become positive. What will happen is we get 1 over square root 7r squared times the quantity a squared plus b squared plus c squared. But the interesting thing is, remember correctly, a squared plus b squared plus c squared equaled 7r squared. We proved that in an earlier video. We can cancel off the r squareds, and then we get 7 over square root 7. Well, of course, 7 divided by its square, any number divided by its square root will have the square root as its answer. So therefore, the cotangent of pi over 7 plus the cotangent of 2 pi over 7 plus the cotangent of 4 pi over 7 equals the square root of 7. So again, we have a trigonometric identity from the heptagonal triangle having the square root of 7 as part of its answer. It seems to appear a lot here because of that a squared plus b squared plus c squared equals 7r squared. And from that, if you remember, we get b plus c minus a equals the square root of 7 times the circumradius, or the square root of 7 times r. And as you can see, that was playing a role here into getting us that answer of square root of 7 when we add those three cotangents together. And I wanted to show that to you today. All right, I hope you enjoyed this video. I enjoyed making it. This is Geek 37 signing off.